Okay, these are the examples that I presented to the class last Friday. The lesson was solving exponential equations. Okay, we were solving exponential equations. We used logs for some, and for some we used graphing, the graphical method, because sometimes some exponential equations cannot be solved algebraically. So for the examples that I used the problems from page 172. The first one was problem number 11, and it was 16.3. 1.072 to the power t equals 18.5. Okay, how do we know that this is an exponential equation? Well, that's what we have discussed when we define exponential equations. We know it's exponential because the variable t is used as an exponent. Okay, you see it as an exponent. So what we do first here is to isolate the expression where you see the variable t. So we want to get rid of the 16.3 by dividing both sides by 16.3. That's your first step. So this cancels out. 16.3 divided by 16.3 is 1. On the left side, you're left with 1.072 to the power t. And on the right side, you have 18.5 divided by 16.3. Okay. Now, so we have isolated the expression with the exponent t. In order to bring that exponent down, we're going to get the logarithm of both sides. Whatever you do on one side, you should also do it on the other side. Remember that rule? So we're going to do log. So we log this. We get the log of that and get also the log. Okay, maybe I should do it like this. So we do log of 1.072 power t, and then also log of 18.5 over 16.3. Okay, you might have wondered why I did not divide 18.5 by 16.3. As much as possible in our solution, we don't do decimal approximations, because once you divide that, you're gonna come up with a decimal and then you start rounding up. So to avoid that, we just leave it like that, leave that expression as it is, and then we let the calculator do the job of finding the final answer. Okay, so we log both sides, and on the left side we see that we can apply the third property of logarithms, which is to bring down the t, and then multiply by log of 1.072. This is the third property, and then the other side will just be the same, log 18.5 over 16.3. And then so now we see that we can isolate the t here by dividing both sides by log of 1.072. Divide the right side by log of 1.072. This cancels out, and using your calculator you can see that this will be approximately 1.821. Okay, you can pause this now and try to check if you're gonna get that same answer. Okay, so now let's move on to the second problem, the second example that I used, the second problem that I used. It was number 12, which says 13e to the power 0.0881 t equals, okay, maybe I should bring this down a little bit. It's too close to the, okay, E 13e to the 0.081t equals 25e to the 0.03 2t. Okay, as you can see here, I see the t in the exponent, and I see it on the left side, I see it also on the right side. And I see a constant 13 on the left, I see a constant 13 here, and I see a constant 25 here. So what we do is we do some manipulation. We use division, dividing both sides by the same number, so that all of the constants will be on one side and all the terms with variable t will be on the other side. So I would like all the constants to be on the right side, so what I do is, let me erase these arrows. What I do is I divide this by 13, I divide this by 13. That cancels out, so I'm left with e to the 0.081t equals 25 over e to the 0.032t over 13. And then I see that I have to move this term here. I have to move this to the left side. So I will now divide both sides by e to the 0.032t. I divide this by e to the 0.032t. And so this cancels out. And you're left with e to the 0.081t over e to the 0.032t equals 25 over 13. Okay? And then you can see that on the left side I have a fraction. I have two powers of e. I have the same base e, right? I have the same base e. So I can now apply the second law of exponent. If you remember, if you recall, the second law of exponent says if I have x to the power n divided by x to the power m, I have the same base, right? That will be equal to x to the n minus m. We simply subtract exponents. This is the second law of exponents. So doing this, applying that law here, you will come up with e to the 0.081 minus 0.032 will give me 0.049t equals 25 over 13. And then now we can do log both sides, right? We can do log both sides. Now, I can always do log. It's going to give me the same answer if I also do ln. Now, why would I do ln? I would like to do ln because I see base e here, and we know that ln, the natural log, is the logarithm with base e. So since I see a base e here, I'm going to do ln both sides. So this becomes ln of e to the 0.049t equals ln of 25 over 13. Okay, so now we learned from the properties that the ln and the e basically cancel each other out. So the left side will now become 0.049t because the ln and the e cancel each other equals ln what was it, 25 over 13, right? ln 25 over 13. Is it the one? Okay. And then, so now you can see that to eliminate the t, you just have to divide both sides by 0.049, and you have isolated the t on the left side, so that cancels. You will have t equals whatever is ln 25 over 13 divided by 0.049. Okay, try this with your calculator, you should be able to get 13.345. Okay. At this point, you can always pause the video while you try to get that answer from your calculator. Okay. Now the third problem that I used was same page, on the same page, but this time it was problem 13, and it is 87 e to the 0.066t equals 3t plus 7. Okay. Just by observing, looking at the equation, the left side and the right side, you can see that on the left side, the t is actually an exponent. But on the right side, I can see that t is just a factor there. It's not an exponent. So there's no way we can do this algebraically, okay? We have these type of problems. You should be able to recognize that it can't be done algebraically. So we have to do this graphically, okay? So using your graphing calculator, you're going to enter the two equations. Y1 equals 87 e to the 0.066t, and then y2 will be 3t plus 7. By the way, that t, when you enter it in the, when you enter your equations, you change it to the x. When you press the button that says xt theta n, what comes out is x. Okay. And so, graphing this, you will see that they won't be able to intersect. Okay. Now, as what I have said, when I introduced to you the graphing, you have to play around with the window, because the not having the right window will result in you not looking at the correct graph, right? So you have to, as what I keep on telling you, you need to play around with the window. The best window for this would be x 0, 50, meaning for the x minimum it's going to be 0, for the x maximum it's going to be 50. So in your calculator, when you go to the window, it's going to ask you for x minimum, right? So for x minimum put 0, and for x maximum put 50. Okay, this is your minimum and this is your maximum. And for the y, my window was 0, 500. So the minimum for my y was 0, the maximum is 500. And for the scale, the x, it also asks you for x scale, right? So for x scale, usually we just keep it as 1, x scale, and even with the resolution, just keep it as 1. Now if you do the graph correctly, you should be able to see that the graph would look like this. This is the exponential one. It should go like that. And then your linear, sorry, what happened? Okay, the linear one, the 3t plus 7, the 3x plus 7, would just be a line that goes like this, and they will never intersect. They will never intersect. So your answer to this problem will be no solution, because they do not intersect. Okay. Okay, so those were the problems that I used as examples. Now, I also assigned to you classwork, some problems from page 174, and I want to do them here too. We didn't have time to discuss this. I just told you that the answers are at the back of the book, but since I'm doing this video, I might as well discuss this with you now. So number 27, letter A says e to the x plus 3 equals 8. Okay, actually most of you already got this in class, but I'm just gonna include this here. I'm gonna discuss all of the problems in the classwork. Okay, so I see the x as an exponent there. I see the base e. I am now going to do log both sides, but since my base is e, so I would rather use ln. Remember I told you I can use ln or log. The answer is going to be the same. Okay, so I use ln because I see the base e, and when I see an ln of e, or e to the ln, I know that they're going to cancel each other, so this becomes x plus 3 equals ln 8, right? And to isolate the x, I'm going to do a minus 3 minus 3, so this becomes x equals ln 8 minus 3. Okay, so you don't get tempted to subtract 8 by 3 and get ln of 5. I would suggest you put parentheses around your 8. That means the value of ln 8 is to be subtracted by 3. Okay? And if you use your calculator, you should get the approximate value of this will be, okay, the back of the book said 0.9206 negative. Okay, try it out in your calculator. Okay, now for B, let's take a look at B and see if this space is enough. Okay, B is 4, 1.12 to the x equals 5. Okay, so I see an x there as an exponent, but I see a 4. I need to get rid of the 4 first, this 4 here. So I'm going to divide both sides by 4. That cancels out, and I'm left with 1.12 to the power x equals 5 over 4. Okay, to bring down that x, I have to log both sides, right? I can do ln or I can do log. Okay, this time I'm just going to do log. So log of 1.12 to the x equals log of 5 over 4. Then I use the third property, which tells me that I can rewrite that as x log of 1.12 equals log of 5 divided by 4. And to isolate the x, I want x by itself, so I divide both sides by log 1.12. So the right side becomes log 5 over 4. Don't divide that. Let the calculator do it. And log 1.12 divided by log 1.12. Okay, if you use your calculator for this, you should get the answer 1.9690. Okay, you can always pause this video to give yourself time to try that out. Okay, I think I can squeeze in. C here. I think this is enough space for C. C is e to the negative 0.13x equals 4. Okay. I'm going to do some shortcuts now. I don't have enough space, so the e to the exponent with an x is already isolated there, so I'm just going to do ln both sides, so this becomes negative 0.13x ln of e equals ln of 4. Okay, I know that ln of e is 1, that's why the ln and the e cancels, right? Because ln of e is 1. And so I'm left with negative 0.13x on the left and ln 4 on the right. So for x, I need to do ln 4 divided by negative 0.13. And using the calculator, you should be able to get negative 10.6638. Okay. Now, let's move on to D. D is log of x minus 5 equals 2. Okay. The variable x is inside that parenthesis. It comes after the log. It's not an exponent right now, so I can't use the third property, right? So what I do now is, okay, I see a log. I see a number on the other side. This is logarithmic, and we learned on our first day of exponentials and when I introduced you logarithms, we learned that we can always convert logarithmic equation to exponential and exponential to logarithmic, right? So this is logarithmic. I am now going to transform this to exponential. So this is log, and I don't see a number here, right? I don't see any number there. So that means I don't see a number. That means it's understood that the base there is 10, right? So when I write this in exponential form, this will be 10 base, right, to the power 2 is equal to x minus 5. Okay? If you don't remember this, just go back to your notes. When was it? Like Thursday, I think? I think Thursday I introduced logarithms. Yeah. So just go back to your notes there. Changing or transforming logarithmic to exponential. Okay? I give you some examples there. And then, okay, let's simplify this. 10 squared is 100 equals x minus 5. You do a plus 5 both sides because we want x by itself. So x equals 105. That's it. You're done. Okay? Now e. Let's see if I can fit e here. 2 ln 3x. Oh, I did this in class. Right? Anyway, I'm just going to do this again. So, I see a 3x there inside that ln. So I will try to clear out all the other numbers there, right? As to isolate that ln 3x. So first I do a minus 5. Minus 5. Don't divide yet. Do a minus first. So that's 0. 2 ln 3x equals 3. Then I divide by 2. Divide by 2. This gives me ln 3x equals 3 halves. Okay. So I see an ln. I am now going to, and it's only on one side, so I am now going to transform this to exponential. Okay, we know that if it's ln, the base is e, right? So to put this in exponential, I'll try to put the continuation here. Base e to the power 3 halves equals 3x. So to get my x, isolate the x, right? So I divide by 3. My x therefore is e to the 3 halves divided by 3. Make sure that when you, it depends on the calculator. If you are using TI-83, then make sure you put this in parentheses here. The 3 divided by 2. Make sure you put that in parentheses. But for the TI-84, you don't need parentheses there. Okay, so give yourself time to, if they say give exact answers, then you can leave it like this. This could be your final answer. That's an exact answer. Now, if you want the decimal for this, okay, E. The decimal answer for this is 1.4939. Okay, that's E. Okay, now let's do F. F is ln x minus ln x minus 1. Oopsie, what happened there? What happened there? Okay, I'll try to read. Okay, I can't. Ooh, there you go. Okay, so ln x ln x minus ln x minus 1 equals 1/2. Okay, so I see 2 ln's on the left side. I need to combine them into just one ln. And I use the property, the second property I think, which says ln of a over b is equal to ln a minus ln b. But I'm going to use the reverse of this, okay? Because what we have is the difference, right? So I do the reverse of this, I apply the reverse of this, and so my expression will be ln of x divided by x minus 1. Okay? Since my a would be the x and my b is the x minus 1, equals 1/2. Okay. I see ln of something. Ln of something equals a number. So again, we change this to exponential. So the base for the ln is e. The exponent is 1/2. And that's going to be equal to x over x minus 1. Okay? Okay, now I need to have just one x, right? So what I do now is I put over 1 here and I cross multiply. Actually, you can also do this by multiplying both sides by x minus 1. I always cross multiply, like whenever I see a fraction on the left equals a fraction on the right, I cross multiply. So what we have is 1 times x, which is 1x, and then equal to the other side will be e to the 1/2 times x minus 1. Okay, then I distribute this, I distribute that. This becomes e to the 1/2 x minus e to the 1/2, because e to the 1/2 times -1 is e to the 1/2. On the other side I have 1x. Okay, now I have to put all these x terms together, right? I have to put all these x terms together. So I will have 1x minus e to the 1/2 x equals negative e to the 1/2. Since I decided to move the e to the 1/2 x to the left side, right? I wanted the x's on the left side. Of course, you can also put all the x's on the right side and then put the e to the 1/2, the negative e to the 1/2 on the left side. You're still going to get the same answer. You learned that from algebra. Anyway, so what I have now is, okay, I'm going to go to the next page. I'm going to copy this down. 1x minus e to the 1/2 x. Okay, I'm going to rewrite that. 1x minus e to the 1/2 x equals negative e to the 1/2. Okay, let me see again. Equals negative e to the 1/2. Okay, so I got it. So now I want x by itself. Since these two terms have a common variable x, so I can factor out the x, right? The term is factor out the x. And so I'm left with 1 minus e to the 1/2 inside equals negative e to the 1/2. Okay? Okay, finally I have x by itself. So I divide this by 1 minus e to the 1/2. I divide this by 1 minus e to the 1/2. So x becomes equal to negative e to the 1/2 divided by 1 minus e to the 1/2. If they want exact answers, then that's it. You end there. But if they want decimals, then you should be able to do that with your calculator. Actually, you can also rewrite this as negative square root of e. I don't know. I think the more simplified form is the one with the power 1/2. But for easy entering of the values in the calculator, it's easier to, I think it's easier to do the square root rather than power by half. But anyway, either way, any of these two forms is acceptable. And then you enter this in the calculator and you should be able to get an answer which is 2.5415. Okay, so now let's move on to the next one. The next problem is G, and G is e to the x equals 3x plus 5. Okay, just by looking at this, you can see that the left side is an exponential, e to the power x, so x is a power there, and on the right side, it's linear. So, the same as my third example, remember I used those three examples, problems 11, 12, 13, so I think it was problem 13, where you had exponential equals a linear, so in this case, you need to do graphing, right? So, grab your calculator and input this, e to the x, and then y2 will be 3x plus 5. So one should be linear and the other should be exponential. Now for my window here, I'm just going to tell you what window worked for me here for the G. My window was, of course I would like you to play around with the window by yourself, but if you don't have much time, then I'm suggesting this window. This was my window, okay? And with that window, I was able to get this graph. My graph looks something like this. Okay, this is my e to the x. That was my e to the x. And then I got a line that's 3x plus 5 somewhere here. So I see two intersections. This intersection and this intersection. I'm going to use second trace. I told you how to do that, right? Hopefully you still remember. So do second trace intersect, and you should be able to get these two intersections. The x values are negative 1.599 for this one here, the one on the negative side, and the other one is 2.534, this other point here. Oopsie. Okay. Guys, if there's still any one of you here that's struggling with a calculator, you can always come early. I'm always there by 7. We can always practice. I can help you out with how to find intersection points or find values, like any of the graphing calculator questions that you may have, okay? Can be before school or after the class. I can stay for a little bit after class too, okay? So G and then H. Okay, H is another one of those equations where you have to do this graphically. Like, there's no way you can do this algebraically. So for this one, my window was this. I did negative 5 to 5, and my y was negative 2 to 20. And my graph looked like this. Okay, so the exponential 3 to the power x should look like that, as any exponential functions, right? And then the x cubed is a polynomial function with an odd exponent, so it went like this. It went like this, like that, and then there was an intersection point somewhere here. Okay, and that intersection point, using second trace, you should be able to get that intersection as 2.478 the x. We're just interested with the x, right? Because we're solving for x here. And then the last one, I need to go to another page. So I is ln x equals negative x squared. Again, just by looking at the equation, you can see that there's no way you can do this algebraically, so you have to do this graphically. Your y1 will be ln x, y2 is negative x squared, or you can reverse that, doesn't really matter. Now my window for this was -5, +5, and y minimum -5 and maximum +5, and I got this graph. So the ln, since the ln is actually the inverse of the e to the power x, so it looked like this. That's how it should look like. That's for the ln. And then the negative x squared, so that's a parabola opening down. It looked like this. That's the parabola opening down. And so they intersect at this point here, which is a positive x. And using second trace, number 5, you should be able to get 0.653. Okay? So, I hope you understood the discussion here. If you still have questions, you can always email me or any of the mentors. And I will try to post a link to this in the Google group. So I will be experimenting right now. So since this it's about 36 minutes and 31 seconds, so it's rather long. So I think I would upload this on YouTube. Okay, so that's it for now.